Hello, welcome back. I'm Andreas Chat, your tech-curious web designer. In this video, we will encrypt the messages in our inbox so not even admins can inspect them in the database. The topic of encryption is a science by itself, and there exist many different levels of security and complexity. Before we dive in the code, let's first have a quick introduction to the world of cryptography. A quick shout out to my newest supporters on Patreon, Brent and Louise. Thank you so much for your support. So cryptography is the science of securing communication and information by converting it into a form that is unintelligible to anyone except the intended recipient. There are many areas in the field of cryptography, but two of the most important ones are hashing and encryption. Hashing deals with identifying and validating data. So we hash, for example, the user's password in Django, meaning we are not actually storing the password itself, just a hash or fingerprint of it, which is always the same with the same input. Hashing is a one-way street. There is no way to get to the password if you have a hash, only by guessing. Encryption, on the other hand, deals with confidentiality of data and is used to encrypt and decrypt text, for example, to establish a private conversation. This is a two-way street, and with a secret key, you can retrieve the original message again. Now let's take a look how these two practices work on a fundamental level. When we hash a password, we send the string the user submits to a hash function. There are many different algorithms which can be used here. A very secure one is, for example, SHA-512. But with this function alone, a certain password would always have the same hash in the database, which would be easy for hackers to figure out. That's why we use salt. So salt is just a string of random variables we add to the password before it's hashed, creating each time a unique hash. Then the hash and the salt are stored in the database. With encryption, we first create a secret key. With this key, we will encrypt the original text, also called plain text. The algorithm to encrypt and decrypt is called a cipher. A widely used cipher, for example, is AES, which stands for Advanced Encryption Standard. Then the encrypted text, called the ciphertext, is stored in a database. To decrypt the ciphertext, we need the same secret key, so this key needs to be stored in a secure location. When we use the same key for encryption and decryption, we call it symmetric encryption. A safer method is using two different keys, a public key and a private key, which are mathematically linked to each other. This is called an asymmetric encryption. We use here a public key to encrypt and a private key to decrypt. Although this method is safer, it is also slower, requires larger keys and leads to a larger ciphertext. So this option is best for highly sensitive and shorter text forms. It is used, for example, for digital signatures. Alright, in our case we will use symmetric encryption using one secret key. Now that we got an overview, let's get to our code. There are many encryption packages available in Python, and a couple of them are listed here. They can be found in Python's online package library PyPI. For my encryption, I will use the cryptography package. This is a widely used Python package for symmetric encryption. It is actively maintained and has a high security using the advanced encryption standard under the hood. Alright, so let's get started now. Let's first check out the documentation of this package. So here we have the documentation on PyPI. Let's copy the install command and pip install it in our project. So pip install cryptography. Alright, then let's go to our views.py file in our inbox folder. And let's import the package. So we copy this line here and add it in here. from cryptography.fernet import fernet. Now, what is fernet?
Fernet is an Italian style of liqueur.
Oh, delicious! In our case though, fernet is the name of the class to create our cipher object, and also to generate the secret key. Let's do that now. Here is the code to generate the key. We can generate this key using the Python shell. So the Python shell is a command line interface where we can execute Python code and can see the results immediately. We can access the shell in the terminal by simply writing Python. So I write here Python and then enter. And here we are in the Python shell now, visualized with the 3 arrows on the left. So to generate the key now, we first have to import the fernet class inside the shell. So let's copy it from here and paste it in here and enter. Now that the package is imported, we can generate the key. So we copy this line here and paste it in here, enter. So now this key is created. Now let's print this key. So print key, and we get this string of characters. This is our secret key or encryption key. So this key we will use for encrypt and decrypt text now, and it has to be stored somewhere secure. We will put it for now in our settings file. Later, when we deploy the project to the server, we will put it in environment variables, which can be used to store sensitive data. Okay, let's copy this code. And let's go to our settings.py file. Here on top we have already a secret key. Django uses this secret key, for example, for our CSRF token in the forms to protect against cross-site forgery attacks, but it is also used in session management, among other security features. Let's add our encryption key underneath here. So I call it encrypt underscore key equals, and then we paste here our encryption key string. Actually, the B prefix indicates that this string is in bytes form, which actually represents binary data. Binary data is a raw data format, so the language of the computer, so to speak. Alright, save the settings file. And here in the terminal we can now exit. So we write exit and parentheses. So we have our encryption key now. We can close the settings.py file and go back to views.py. Here let's import now this encryption key, which we need to create the cipher. So we have to import the settings now. And then here we initialize our fernet class using the encryption key. F equals fernet and then in parentheses settings.encrypt key. So F is now our cipher. Okay, let's encrypt now. Let's go to our new message function. So here's our function, and in here we add our encryption now. So I'm adding here comment encrypt message. Alright. What I will do here now is to get through the whole process of encryption and decryption step by step and print it out in the terminal so we see the results of each step. Alright, so first we get the body from the form. Here we're using the cleaned data method to get the content of the body and save it in a variable called message underscore original. Then we transform this string into binary data. This is required for our cipher to work, so we are using here the encode method with the UTF-8 character encoding standard. Then we encrypt the message with our cipher here, so f.encrypt and our message in byte form. And in theory we could store this one in our database now, but for this we would need to change the field in our body property to a binary field. However, I will store it as a string instead, as I ran into some problems when storing binary data locally and in production. The SQLite database we're using locally for our development and the Postgres database we will be using in production handle binary data differently. So to minimize friction, I convert our binary data back to a string now. We can easily do that with the decode method. Now for testing purposes, I decrypt here the text again. So we decrypt the message with f.decrypt. The decrypted message is in bytes form again, so we need to decode it to get to our original message. Alright, this is the process. Now I will add print statements for each step, so we can see in the terminal later what each step looks like. So first in here, I print out the original message. So I'm creating here a label in quotes with colon. Then I have a comma. This creates a space. And then I'm printing out the value of this variable here. So next up are the message bytes. Then we have the message encrypted. And the message decoded. Alright, this was the encryption. And the same statements now for the decryption as well. I print out here the message decrypted and the message decoded, which should correspond to the original message. Alright, let's save this file and let's check it out now by creating a new message. Let's start up the server again. Python manage.py run server, like that. Then let's go to our website. I go to inbox, write a new message. Then I say hi. So here's our new message. Let's check out now the backend, what it has printed in our terminal. So as we can see here, it printed out the original message, which is hi, then as bytes, then encrypted as binary data, and then decoded as a string. This is the form we will save in a database. Then we have the message decrypted, which is again in byte form. And then we have the message decoded, which is the same as our original message. Alright, it all seems to work. Great. Now let's get rid of our print statements here. And let's for now save this encrypted message in our database. So we say message.body equals message decoded. Okay, save this file. Now let's go back to our website and create a new message. Again, hi. And as we can see here, now hi is encrypted in the database. So now let's decrypt this message. To decrypt the message, I will add a method with a property decorator to our inbox message class. Let's head over to the models.py file. So we go to models.py, and in here I import now the fernet class and also the settings. Alright, now let's add the decrypt method. I use here the property decorator. Then I add my method with the name body underscore decrypted. Here I create my cipher now. Then we decrypt the value which is stored in the body property. And then we decode the message. And lastly, we return the decoded message. Alright. Save this file. Now let's display this encrypted text in our template. So we go to the templates folder and to the conversation.html file. So we have here message.body. So instead of displaying the body property, we fetch the body underscore decrypted value. Alright, save this file. If we test this now, it would give us an error message because not all messages are encrypted. So for this to work, we have to delete all the messages in our inbox. Let's go to the admin panel and clear out all our messages. So I will delete all my conversations now, and by doing that, all my messages are gone as well. So conversations, I select all conversations and delete. Alright, now our inbox is clean. Let's create a new message now. So I go back to my inbox, write a new message, write a message to Zozo and say hi. And I'm adding here a bit of formatting now so we can test this as well. How are you? And submit message. Nice, the message appeared correctly decrypted. However, we still have to fix the formatting. For this, we add a class to our HTML element. So let's go to the conversation.html file. And here we add a class whitespace -pre-rep. This will preserve new lines and spaces within our text. So save this file. Let's go back, refresh the page. And as you can see here, we have 2 lines now. Nice! This was the new message implementation. Now let's add this logic also to our reply function. So let's go back to our views.py file. We get rid of this code here because we added the decrypt functionality to our models class. And let's copy those lines of code and add it to our reply function. Here we have the function, and under message here, we add these lines of code. Okay, save this file, and let's check it out. I add a reply here. I add nice to meet you. And then a new line, I add Andreas. Okay, send this message. And there you go. Okay, let's have a look now at our admin panel and see how the content looks there. Okay, let's inspect our inbox messages. And as we can see here, the text is encrypted. As next step, I will make all the fields read-only, meaning an admin can only look at the data, but is not able to edit things. For this, we go to our admin.py file. And we create the inbox message admin class. Like that. With this admin class, we can set, for example, properties to read only. And I'm doing this here with my sender, conversation, and body field. And then we register this class also here. So, comma, and I add a class. Okay, save this file. Let's check out the admin panel again. I refresh the page. And as you can notice here now, the fields are changed to non-mutable. Alright. That's it. That's it, also for this video series, how to create a web app with Django. Thank you so much for watching and following along. If you're now interested to know how to deploy this web app to a web server, stay tuned for the next series. I shall see you very soon. Until then, happy coding! And as always, stay curious, my friends!